All right. ADC is the arc intercepted by angle ABC. So we have been talking about central angles, basically, central angles that come from the center of the circle. Now we're going to talk about inscribed angles. These are angles that are completely in the circle. All the vertex and the 2 points at the end of the ray, although the rays are continuous, but they cross the circle. And so B is the vertex. It is on the circle. It's not on the center of the circle. It's actually on the circle itself. And then the rays that make up the legs or the arms of the angle cross through the circle. So this particular angle is ABC. This is an inscribed angle. Inscribed. It is completely inside the circle. All right. The vertex is on the circle. AB are chords of the circle. Chords of the circle. Now, if we were to draw this angle here, this central angle that goes from XWZ to the center of the circle, and we were to take any point over here and connect to the same 2 endpoints, you would actually find that the angle that is the central angle is double the angle that is on the actual circle itself. Always. It always works out that way. If they start on the circle and go to the 2 points, it's going to be exactly half of the one that was the central angle. And that's where we get actually the theorem at the bottom of that page. If an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc. All right, intercepted arc. Now remember, the measure of the intercepted arc is the same as the measure of the central angle that makes it up. So you have to remember we're talking about intercepted arcs of an inscribed angle. That's different than intercepted arc of a central angle. Central angle and the arc itself are going to be the same. Inscribed angles and the arc are going to be half. Inscribed angle is half of the arc that actually makes it up. So in this case, whatever angle this is, let's say that's 60 degrees, the arc that makes it up is going to be 120. All right, the arc is going to be double the central angle. And they've given us some pictures of inscribed angles. In this case, this one actually goes through the diameter. The diameter actually makes up part of that arc. Or part of that angle. That's perfectly fine. Or it can actually have the center of the circle inside. That's an inscribed angle. Or it can be outside. The center of the circle can be outside the inscribed angle. They still are considered inscribed angles as long as the vertex is on the circle and the legs or the arms of the angle are chords of the circle. All right, those are types of inscribed angles. So let's look at how we use this. Look at example 1. There we go. Measure of inscribed angles. They give us circle O. They say the measure of AB is 140. The measure of BC is 100. And AD equals DC. All right. We're going to go with this. We're going to say that AD, which is this arc right here, equals 140. All right. That's AD. It says BC equals 100. So BC equals 100, that's BC. And then they're telling us that AB equals DC. So they want the measures of the numbered angles, Now here's the deal. We have to figure out then which angles make up what. So if we have AD, we're going to say that's 140. I'm going to actually label it here. And then BC is 100. I have to think about what angle makes up those things right there, all right? So for BC, the angle that makes it up is actually this one right here. Does everybody see that? So 3 makes up BC. Everybody agree? All right, so we're going to say then that the measure of angle 3 should be half of what it makes up. What does it make up? It makes up 100. So what is 3 going to be? 50. All right. And then we have, let's see, what else do we have? We have,
1 and 5 would be the same.
So he's asking if 5 would be the same. Why is 5 going to be the same?
Because they are the same, congruent.
It actually makes up the same arc, does it not?
Yep.
So we have measure of angle 5. Also 50. All right. Now, we need to know, 1, 1 makes up one that we already know, right? So 1 right here makes up what?
140.
Makes up 140. So 1 is going to be half of that. So what is 1 going to be? 70. Okay. And then we need 2 and we need 4. Now, 2 makes up DC and 4 makes up AB. So whatever those are going to be the same, right? Because we know the arcs are the same. But how do we figure out the arcs? 360. We're going to use 360 here. So we're going to say 360 minus the 140 and minus the 100. And what does that give us?
160 or 120.
120. But that makes up 2 arcs that are the same. So what are each of these arcs then?
60.
These are 60. If those are 60, then the angles that make them up, which is going to be angle 2 and angle 4, should both be what? 30.
Yay. This is
The measure, oh no. It says if 2 inscribed angles of a circle or congruent circles intercept congruent arcs or the same arc, then the angles are congruent. All right? So all they're saying is, which we just talked about it, if they intercept the same arc, they are congruent, even if they're on different circles. So if their arcs are congruent, the angles are congruent. Inscribed angles are congruent, okay? If arcs are congruent, inscribed angles are congruent. If an inscribed angle intersects a semicircle, the angle is a right angle. That's important because you're going to use this. If your angle intercepts the semicircle, so if I were to draw from one end of the angle to the other, I would actually be on the diameter, okay? On the diameter. So that means if my endpoints of my angle hit the diameter, then that angle is a right angle, always. If my endpoints are on the diameter, then my angle is a right angle, always. It's always true, okay? So we're going to use that with this next example. Let's look at example 4. Triangles ABD and ADE are inscribed in circle F. With AB congruent to BD, find the measures of each numbered angle. The measure of angle 1 is 12x minus 8, and measure of angle 2 is 3x plus 8. And they want all 4 angles. All right, so let's look at what they gave us. They said AB equals BD. Now that looks more logical. All right. AB equals BD. What did they just tell us?
3 and 4 are congruent.
3 and 4 are congruent. All right. And then what do we know about this angle here and this angle here? Their endpoints are on what? The diameter. So they form a semicircle. So what are both of those?
90 degrees.
They're going to be 90 degrees. So that's 90 degrees and that's 90 degrees. All right. How does that help us?
You can solve for 2.
Yeah, so 1 and 2 they gave us. What should those add up to? If the third angle in that triangle is 90, what should those 2 angles add up to?
90.
So 12x minus 8 equals, plus 3x plus 8 should equal 90, right? So far, so good. If these arcs are congruent, what do we know about the angles that make them up? They're also congruent, right? What do we also know about those in that triangle? Not only are they congruent, they add up to what? 90. Why do they add up to 90? Because this is 90, and it's in a triangle. So 90 plus the other 2 should equal 180, which means the other 2 must equal 45 each. All right? So to solve for x, we're just going to add 1 and 2. This is the measure of angle 1 plus the measure of angle 2. That should equal 90. And then we know that the measure of angle 3 plus the measure of angle 4 should equal 90. But something else we know is they equal each other. So that means they're both 45. So we can very quickly find these guys right here. These we need to solve for. All right, 12x and 3x.
15.
That's 15x. Negative 8 and positive 8 cancel. Let's make this a different color. So x equals 6. We have not finished. They asked for the angle measure. We need to actually find the angle measure to answer the question. We're going to plug in a 6 here for the measure of angle 1. 12 times 6 is 72 minus 8.
64.
64 degrees. For measure of angle 2, we're going to plug in a 6 here.
18.
26. There we go. Let's look at this one. Pull back from your brains here. Quadrilateral ABCD is inscribed in the circle P. If the measure of B, that is the angle B is 80, and the measure of angle C is 40, find the measure of A and D, all right? So they have given us that this measure right here is 80, correct? They have given us that C right here is 40, okay? We need the other two. All right, so first we're going to look at what B makes up. B makes up from A all the way to C, right? Doesn't it? Do you agree that the endpoints of that? So A to C then in arc length should be what? What should this be? This arc length should be what? It's going to be double 160, right? All right, and so let's look at the other one. Let's look at what else we know. We know that this is 40. That makes up from D to B, right? That is 80, okay? So now I need to say, what do the other two make up? So I have angle D, all right? So I have angle, I didn't finish writing that one. Angle D. So let's erase some of this so we can see just angle D here. Just angle D. All right, so we have 80 all the way over here, right? And then if I look at D and A, I need just A. I could possibly calculate all of this, right? How would that help me?
360 minus 80.
Yes, 360 minus 80. What does that give me?
280.
280. That tells me the arc length. Does that help me with the angle?
Yes.
It doesn't? It does. How does it help me with the angle? Yeah, so the measure of angle A should be 140. All right? Now, there's a couple ways to think about this. This is 140. That is 80. I have a quadrilateral. You can do this however you want, but the easiest way is all quadrilaterals add up to what? There's 4,
360.
right? So n minus 2 times 180. 4 minus 2 times 180. All quadrilaterals add up to 360. I have 3 of the 4. I have A, I have B, I have C. I just need D. So what do I do?
And subtract from 360.
Mm-hmm.
So 120 plus 140 is 260. 360 minus 260 is 100.
There we go. Does everybody see what we did? So you're using all of your knowledge to figure out what you have and what you need. What you have and what you need. Okay. This. So 140 and 40 is 180. 80 and 100, 180. When a quadrilateral is inscribed, opposite angles are supplementary. They add up to 180, which is what just happened in this one. So just read through the theorem. We just kind of actually figured that out when we did. That's what this theorem says. All right. When the entire quadrilateral is inscribed, opposite angles are supplementary. Try those two.